Good afternoon, good evening, or good morning, depending on where in the world you are. Thank you for attending this panel discussion. My name is Ashar Baig. I will be moderating the panel discussion. The topic for today is software-defined networking in the real world. We have a distinguished panelists on this call. This group consists of Ben Kepes, who's the Director of Diversity Analysis and an analyst in the GigaOM Analyst Network. Greg Ferro, an independent analyst for Tunnel Mine and Packet Pushers, another analyst in the GigaOM Analyst Network, and Charles Ferland, who is the VP of Business Development at Nuage Networks. So without further ado, we're going to talk about what are the business and technical benefits of software-defined networking? What are some of the ideal use cases? We will hear three particular use cases of SDN technology. Some of the opportunities presented by this technology, constraints and realities, and where to start, how to proceed, and we'll also talk about some of the successful deployments. So I just wanted to quickly pass the baton over to Charles, who will tell you about Nuage Networks, who's the sponsor of this webcast. He will just go over two very quick slides to lay the groundwork, and then we'll begin the panel discussion right after Charles is finished. So Charles, over to you.
Yes, hello, thank you very much. And thank you for taking the time to speak with us and giving me the opportunity to introduce Nuage Networks. Nuage, first of all, is the meaning of cloud in French. So it's not new age or whatever. It's cloud in French is simply Nuage. So Nuage Networks is it's our name, and obviously we're focused on cloud solution at this point. We are a venture of Alcatel-Lucent Group, so we are operated and based in Silicon Valley in Mountain View. What we provide as a solution is really a network virtualization, or also known as overlay type of technology that is integrated in most popular hypervisors out there. So we also provide connectivity and integration into cloud management systems such as OpenStack, CloudStack, and so forth. But what really has a key unique advantage for us is we do a tight correlation between the overlay, what we're learning in network virtualization, and with the existing infrastructure, what we call the underlay. So many of the overlay type technology operate as ships in the dock. We have a little part uniqueness that looks at actually the information running in the IP routing environment underneath and the MPLS environment running underneath our overlays, and we're able to correlate that and take action and reprogram some of our overlays or do different things slightly different in case of a disaster recovery or in case of a major failure here. We also provide what we call policy-driven networking policies. So basically this is an abstraction of the overlay, is an abstraction of stop configuring OSPF and VLANs and specific IP address, where we make abstract network policies and we convert them and apply them into the networking context in virtualization vSwitch. We currently have a little over a year, almost a year and a half of existence. We have several accounts around the world right now, in Asia, in Europe, and in America, and across multiple different industries. Not one in particular. We have been successful in the finance area, in the healthcare area, or even in the retail and telco space. So for now, I think SDN solves some of the issues across multiple industries and across all regions of the globe. So if we move to the next slide, it gives you a little overview of our infrastructure. Nuage Networks solution is the virtual service platform, or VSP. The VSP is comprised of three components, right? One of them is the VSD, which is a virtual virtualized service directory, and this is where we declare these policies that I referred earlier on. This is where we make our policies say, well, this web application network is able to talk to this database application network with these conditions and these policies and these quality of service and so forth, right? This, for example, we would define some what is called service chaining, where we say, well, this network is only allowed to talk to this network. Let it first go through a firewall. So we use an abstract GUI interface to define these policies, right, without having to worry about a specific network equipment on which it's running, right? Next step is actually a virtual service controller, or the VSC, right? And the VSC is actually where it converts the policies into some specific IP entries in your IPA routing table, or it runs, or it converts that into a really concrete IP address, TCP port, and so forth, and goes and program this into the virtual switch. So here, what's important, I referred earlier on that we were listening to the underlay, or we were aware of the IP environment around us. The VSC is actually leveraging some of the Alcatel-Lucent technology called the SROS, which is one of the world's most popular IP routing platform. And so it's a carrier-grade routing platform that we're running in here in our controller. And the way we're able to scale this is simply by adding more of these VSCs. They could be around the globe, distributed in multiple data centers, and we use a simple NP-BGP protocol to scale, just like the internet does, really, to scale our solution from one controller to two controller and so forth without any major limitation here. So scalability is perhaps one of the key advantages as well when we're talking about an efficient control plane. And finally, the VRS, which is the virtual routing and switching component, this is really a virtual switch that is embedded inside the servers. This is a vSwitch that is in most popular hypervisor and really gets the programmability, the messaging, and the information on how to move information from the virtualized service controller, the VSC. In case you don't have all your data center virtualized, and you have some bare metal services, and you have some servers that are not using any server hypervisor technology. Nuage Networks also provide a gateway for these type of services, and we have a bare metal gateway which allows to bring the bare metal servers and to link them into the overlay type technology and apply the same policy-driven concept that applies for the VM to these physical servers. So really, it's a compromise of three solutions, three components that comprise the VSP solution. One of them is the VSD, where we declare our policies. The VSC, which really take these policies and goes and program IP routing information directly into the virtual switches that resides inside of the hypervisor or inside of the server. So this, in just a few minutes, is more or less the Nuage network solution.
Thanks, Charles. So now we will, as a panel, discuss some of the business drivers and for software-defined networking. I know taking the controller function and separating them has some advantages, but those advantages are only as good as the benefit that they provide. So I've listed some of the key business drivers on this slide that you're looking at right now. So I'm going to turn it over to our first panelist, Greg. Greg, can you take us through some of these business drivers? Let's talk about agility and mobility first.
Sure. So in infrastructure, if you're managing an infrastructure team today, one of the biggest problems you've got is two key issues around agility and mobility, and they sound like the same thing, but they're kind of not. Agility is it takes a long time today to implement new services in a data center or in your infrastructure. So delivering a server requires storage instantiation and networking instantiation of things like VLANs and firewall rules, and getting access to compute resources and getting allocations of stuff and getting disk images prepared. In an agile environment, or in a typical environment today rather, you're talking about 12 weeks is fairly typical in most ITIL compliant enterprise network infrastructures, and that's just not good enough. We need to reduce it from 12 weeks down to 12 minutes. So the business driver behind SDN and the sort of introduction that we got there from Nuage and the sort of SDN overview with this abstraction and tools and utilities is how can we configure the network in 12 seconds or even 12 minutes and instead of waiting 12 weeks. So the business driver is for that agility. And the second one is mobility. The arrival of hypervisors, the arrival of software-defined storage, or the emergence of software-defined storage, and the emergence of SDN, they're the two emergent marketplaces, is largely driven by the fact that servers are now mobile in the data center. You want to have it installed as a virtual machine on this hypervisor, and if it moves over here on this hypervisor, then fine. The trick is, of course, is that both storage and networking have never had this capability, and networking in particular has always assumed the server is static, and if it moves from here to here, 15 minutes, half an hour, that's okay. It's good enough because it doesn't move all that often. But a new network needs to support mobility, but more importantly, that mobility needs to be programmed. So an application needs to come up and say, that server's moving from here to here, and the network needs to make the change seamlessly and on the fly. And that's not what we do in networking today. We can't support, we have these designs or architectures in our infrastructure which are brittle and fragile. And what I mean by fragile is if something moves from point A to point B, it can cause loops and collapses in the networking infrastructure. And it's fragile. When the collapse happens, the network actually just completely melts down. And sometimes you see entire data centers go offline because of network failures. So agility and mobility both drive into the second point that we list here, which is time to market. So if we could use mobility to move resources around the data center to where they need to be, put them on the biggest hypervisor or the smallest hypervisor because the workload is low. If we were able to provision in minutes instead of weeks, then we're able to get a product to the market for our businesses in a much more practical, a much more realistic time. Request comes in from the marketing department. Oh, we've only got 2 weeks to set up a website and take advantage of this campaign window. The IT infrastructure team can now provision the network quickly and at speed. Does that make that a good description there?
Excellent description. I just have a couple of follow-on questions, but before I do that, a couple of housekeeping items. I'm getting some pings from the audience. This webcast is being recorded, so you will have the recording that will be posted onto our website. The slides that are being presented in this webcast are also going to be available, so feel free to take notes, but mind you that the slides will be available right after this webcast is finished. So going back to the follow-on question, so Greg, you mentioned 12 weeks. This is how long it takes us today to provision a server. Are you talking about hardware procurement times as part of those 12 weeks? From the time you order the server to the time when it gets in and you provision it and procure it, so is that the full procurement process, 12 weeks?
No, not normally. Normally it's 12 weeks just to go through in the normal enterprise network, when you're provisioning a new service, you break up your request into some compute and some storage and some networking, and then all the teams go off and decide what it is, and then a network architect will take his networking request and turn it into firewall rules, port allocations, is there spare ports available on switches, is it, where's the bandwidth, what does it look like in the network, and go through a whole sort of design process that really doesn't add a lot of value to the process. It's based on this idea of scarce resources, and really in the modern network we've got lots of resources. What we need to be able to do is manage those resources better. I suspect we'll talk more about resource scarcity and plenty in a bit, but it's not about buying hardware, although sometimes it can be. Most data centers don't usually buy new hardware to deploy new services unless there's something unique or we're out of resource in a specific area. It's really about the process of change control. We request a resource, we validate that the resource is available, we allocate capacity, somebody then goes and executes on some tasks in some sort of change window, which usually has a 2 to 4 week change request approval cycle, and then finally things are delivered by usually by some manual process where somebody gets up at the keyboard and bangs away on the network and says conf this, configure this, do this, and it's just not very efficient. So no, it's not even normally including the purchasing cycle. That gets out even longer.
Excellent, thank you. And
Greg,
one more reminder for the audience that this is an informal panel discussion. Please submit your questions using the questions button in your GoToMeeting bar, and I will be fielding those questions and asking those for the panelists. If you have a specific question for a particular analyst, please mention them by name. Otherwise, I will just pick the appropriate person that's most knowledgeable in that topic. So moving on,
Greg,
there's a comment.
Greg, just
yes,
just 1 second, Ashar. Just maybe in the defense of the networking folks out there, to configure a VLAN or to configure an IP address, it doesn't take 12 weeks, and we all get that, right? Somebody can say, hey, why do I need SDN? This doesn't apply to me. I can deploy a new VLAN in just a few minutes, right, or a few seconds. The inefficiency you pointed out quite rightfully comes from the cross-functional request. So from this workload, a server is provisioned, and then there's an IT ticket that is opened to say, well, please, we'll need to configure the network and assign a VLAN. And then the networking person, oh, is it VLAN 101? Oh, sorry, I'm at this VLAN ID or this IP subnet, or it's this back and forth that really drives the inefficiency and how we end up with the delays we're talking about here. So having a common orchestration platform that looks at servers, looks at workloads, looks at the storage and the networking in one go, in one orchestrated, automated environment, that we can define these networking templates and reuse them over and over and over and over again, is really where the efficiency comes in, and you stop having to do this manual process one after the other on equipment that is from vendor A and slightly different from vendor B, and vendor C
this
is
predictability,
release it.
One of the things that businesses tell me is that predictability is really, really important. The ability to be able to say, when somebody makes this change, it's predictably reliable, or it predictably occurs at a certain time, or predictability, when I do something, it's going to happen exactly this way every time, sort of like the McDonald's model. The burger might always be bad, Yes, Ben.
I think to riff on that theme, that's really an interesting theme, and that there's some macro trends occurring here. If you look at enterprise IT, and if you look specifically at sort of the development process, we see more and more common building blocks are being abstracted away to third parties. At the end of the day, if you need to build email into your application, whatever your application is, you're much more likely to use one of the email vendors, SendGrid or Mailgun or one of them, rather than building it in yourself and having to wrangle SMTP servers and all those sorts of things. And so what we're seeing is abstracting out all the sort of component parts, all of the if you like, the plumbing and infrastructure that's the undifferentiated heavy lifting. And so I think there's some real themes in terms of what we're seeing with SDN. We're seeing that, so we get flexibility and predictability, but we also get the opportunity to kind of offload some of that stuff. We don't have to wrangle hardware anymore.
So Greg quickly touched upon on the time to market, and then Ben also mentioned about the cost savings. So we have some audience members. Barakan, who's agreeing with saving time, money, capacity, and efficiency. So in that spirit, I want to move on to the next business driver, which is actually I'm going to pair them together: infrastructure efficiency and increased hardware utilization. They're kind of related, even in consolidation. Those three, I wanted to pose that question to Ben. Ben, can you expand on those business drivers?
Yeah, so I always tend to simplify things and use analogies, and I guess the best analogy here is the virtualization space. And so for over the past 10 years or so, what we've seen is a move from organizations having to buy physical servers and rack and stack those physical servers to virtualization, where they can either gain more efficiency out of the servers they have. They can run virtual servers on multiple virtual servers on them, or they can even abstract that out to a third party through the cloud. And so what we're seeing is again, macro trends. I always look at the big underlying macro trends, and post GFC, we've basically got a situation where organizations are being told, you have to be agile, you have to deliver more, you have to gain more revenue, but you can't spend any more money. And by the way, you want to get some cash for CapEx, it's not going to happen. So how do you sweat those existing assets? How do you absolutely maximize what you can get out of your existing assets? Well, you do it by making them more efficient. And so, virtualization, whether it's virtualization on the networking layer or on the server layer or on the storage layer, obviously allows you to do that. And so I'm seeing a lot of, when I go out and talk to organizations, I'm seeing a lot of CFOs who are saying, well, we were at a conference, I was at a conference, and I talked to another CFO, and she explained how she was getting way more efficiency out of an existing static or even a reducing IT spend. And I want to know about this. What's this whole SDN thing? What does that mean for us? And so that's that driver that you can eke much more out of the same old stuff.
At a practical level on using in the network, we've actually run the data center, particularly the data center, at very low levels of utilization until very recently. Sometimes I've seen data centers where the entire network runs at less than 3%. With SDN, we're now in a situation where we have much greater control. So we talked about, if you look at the Nuage platforms with its VSD, VAC, and VRS, its architecture for configuring, it actually reaches inside of the device and starts to expose a lot of information about what's happening inside the hardware. One of the hidden secrets about virtualization is not that it just, as Ben says, increases the utilization. It certainly does. 40 virtual servers running in one physical server is massively more efficient. But what it also exposes is a lot of instrumentation about the actual system itself. So I can see how much CPU is being used and how much memory and the performance of each VM, which was much harder before. And the network, in terms of SDN, this instrumentation phase where we reach in with an external piece of software, we can see what's not being used and start to drive it harder. And recently I just finished doing a survey, and confirm what Ben said. There's no more budget being allocated to enterprise data centers, but the growth is pitched at 20% in terms of demand for resources going forward. Charles, do you want to speak a little bit about hardware utilization? I think it's probably also a good place to start talking about how multi-tenancy plays in this environment.
You're right, and some hardware utilization is a key benefit here, and it's one of the use cases I'll talk about in a few minutes. And we were sort of sometimes forced into buying the newer networking gear because it had new functionality, there was a new features or stuff that we wanted to do that simply the existing hardware was not able to do. And that's a serious upgrade. You need to take out the hardware out, and deploy new networking equipment because of these new functionality. By splitting the functionality of the network and bringing this into the software, we're able now to program these new functionalities. And oh, wait a second, there's something new and cool that comes in, and I want to have this. Well, now we're doing this in the software directly into the virtual switch residing on the server. So effectively, the network infrastructure really only becomes an IP transport layer, if you want, or it becomes a transport layer that doesn't necessarily apply all the latest and greatest of modern networking into the physical hardware. Instead, we do this in software inside the server with the vSwitch, and we keep using the existing infrastructure for a longer period of time. A lot of times we were retiring equipment after 3 to 5 years. Well, that equipment that, as you mentioned, is barely used in most of the time can stay in place. We do all the fancy new networking protocols in the software, and we just utilize a lot more the existing infrastructure and extend the life cycle of this equipment. This is a huge, huge gain for many of the customers that can postpone the hardware forklift for 2 years, for example.
That's you make a good point there, because consolidation also plays on that. You can keep your legacy infrastructure, your existing legacy network, and build another one next to it, and yet work across both using software-defined networking. True?
Yeah, and that's the whole benefit here, that you can sweat those existing assets and you can invest in new stuff when the time is right, and you've got a common and a consistent framework between the two of them. No longer do you have these silos, and similar things happening in storage, where in the old days you had storage equipment from one vendor, another storage equipment from another vendor, and never the twain should meet. Never was there the ability to actually store between the two or think of that as one consistent platform. And now where you're abstracting hardware away from a software abstraction layer, you can start to do that, and that's pretty interesting, pretty exciting.
Yeah.
Now, thank you for all the questions that are coming in online. I have about a dozen and a half or so questions that are yet to be answered, so I will keep asking them throughout the panel discussion. So I will get to them eventually. If I still don't get to them during this webcast, someone will contact you back with the answer to your question. So let me move on to one of the questions that Moti is asking. He read the last bullet, which is increased security, and he's saying, what are some of the security risks of all this benefits that you're talking of? Do they introduce any security risks? So I'm going to ask that question to Ben. Ben, can you respond to that?
You know, at the end of the day, I come back to the same thing when the security question is asked, and that is that, you know, the vast majority of security breaches aren't because of the underlying platform that's being used. It's because of human error. You know, the Target breach from earlier this year is obviously a good example of that, where it wasn't so much that, you know, bad technology was being used, but that bad processes and the humans that run them were in place. And so I think that's the same. That fundamentally, the difference here is that instead of relying on people to wrangle your switching and to move things around and make changes, you're relying on a robust platform, a robust software platform. So all things being equal, I believe that security is better under these sort of abstracted software-defined models than it is under more regular traditional models.
Ben,
one of our customer actually increased the security. One of our customer actually brought a fantastic feedback, right? And you know, maybe to complete what your point, where you're absolutely right to reuse these templates and networking profile automatically instead of typing them and introducing human error, is one aspect. But the other aspect that this customer brought up is to say, well, most of my traffic is east-west now in the data center. Most of the traffic is machine to machine inside the data center. Yet, most of my security appliance and policies and most of my security focus is at the perimeter for my north-south type of traffic coming in and out of the data center. So then, of course, it's, well, we can use security lists or access control lists to isolate the application, to isolate the servers, to isolate the different groups inside the data center. But then realistically, when you say, okay, now let's implement these access control lists, they realize quickly, well, there's a vSwitch that is part of it. Then there's perhaps, if they're using Blade servers, there might be a Blade server switch from vendor A. There might be a top of rack from a vendor B. They might have a core backbone from vendor C. And the access list needs to be programmed differently, and so on and so on. So practically, it was almost impossible for them at scale and efficiently do this type of model in securing their east-west traffic. And
let me just, can I add something to that? There's just one practical, one practical issue here. There's three practical issues here that SDN brings, which touch on what you're saying. One of them is the fact that you can apply access controls at the edge of the data center network, right in the server, right in the vSwitch where the server connects to the logical network. That's one.
Absolutely, absolutely.
The second one is the audit. You can go to the SDN platform and audit everything in your data center. Right? You can't do that today unless you go down in the data center and walk around. When everything's virtualized and exposed to a software platform, you can audit the connection of everything. I just want to break what Ben's down into something very practical and very useful. And the third thing you can do is, because you have control right out where the server connects to the virtual switch or even the physical switch, you can start to create small segments of connectivity. You can create pseudo data centers inside the physical data center. This means you can reduce the size of the, most enterprise data centers today have two segments, the production and the non-production, and a big firewall in the middle. Well, what if you could break that data center up into 50 small segments? And one, you could create a sort of a virtual data center for marketing and engineering, and here's a special project going on for the accounting team who are doing some big data exports. We'll create a segment in the network for that contracting team that's come in, so they can't see all of the other applications in your data center. Those are the sorts of things that SDN does that increase the security model. They're tightly linked with utilization and consolidation. They're so tightly linked, sometimes you don't even realize the benefits that you get out of them. But they're the practical benefits that I've got in the deployments that I've worked on.
So, Greg, I have a question for you that's coming from the audience. It says, how does an SDN controller, it's from Chad, how does an SDN controller communicate or coordinate with the legacy equipment if the hardware doesn't support SDN?
You need to get hardware that has some external API compatibility. Now, in some cases, different vendors' SDN controllers work different ways, and there are emergent standards coming out in this area. So there's no immediately right answer here. We're still emerging into SDN. The best way to get SDN today is to get new networking devices that have new software or modern software on them that support the APIs and the capabilities. And this, what we normally recommend to people is to have a core and what we call a core pod design. And that is that over here is where your network is. Here's your legacy network over here. Build a little pod and start deploying your SDN onto that today. Go and pick an SDN platform like Nuage Networks, put that in, and start to work with it and build your confidence up, right? Remember that data center networks that we use today, when I started to deploy them in the mid-90s, they were very small, of very limited size, and it took us 20 years of working with them to build them up to what they are today. So why not take that organic design model and carry that forward into your data center, buy a couple of small switches to start with, bring in an SDN platform and start using it just for some project, just for something small, and work with that. Now, in terms of what protocols the controllers talk to the switches on, there's lots of different protocols, and what we're seeing now is that there are protocols for different purposes. Some vendors will use OpenFlow, some vendors will use OpenFlow with extensions, some people will use OpenFlow and OVSDB, some vendors have developed entirely new protocols that are still emerging out of standards. The protocol doesn't matter so much as the functionality that you want to get. Don't get so caught up in CPUs and memory modules and spindles and networking protocols, because they matter. They are certainly a valuable part of your product selection process, but they're not part of your business selection process for making the decision to adopt SDN in your network. How's that?
Excellent. I have another question which I'm going to direct to Ben. This came from Valenciana. I probably murdered the name, but the question is, would you recommend, are there any skills that you would recommend besides networking in order for to be a good administrator for this new ecosystem, for example, OpenStack, Linux, programming languages, etc.?
So I think, I mean, not specifically, but what I will say is that SDN, OpenStack, the move to software-defined platforms are all part of a much broader movement, and there's some other traits of that movement. There's the move towards DevOps, where you have developers and operations teams working as one and bridging that huge divide that generally traditionally exists in enterprise IT development teams and operation teams. And so some awareness of what DevOps means, some awareness of some of the more common modern development languages will be useful. But fundamentally, I think what we're looking at here is yes, we're talking about a highly technical change in the way networking is done. But fundamentally, what we're talking about is a culture change within organizations, where organizations become more agile, and the IT infrastructure that supports them need to become agile accordingly. So for me, actually, the important skills are more the soft skills. Obviously, you need to understand networking, you need to understand how these platforms and solutions work, and you need to understand the value proposition that they're bringing. But you need to understand how to manage all of that within the construct of a changing workplace. You need to be a strategic partner. That oft quoted term, but you need to be a strategic partner to the business. So for me, it's with the obvious requisite technical skills, it's more about the people and soft skills that you can bring to the problem set.
I have a next question. I have from the audience. It's from Andre. I'm going to direct it to Greg. Greg, Andre is asking, can you define POD in the context of SDN and data center?
I'm not sure what POD stands for.
It's capital P, small o, and capital D. Andre, if you can clarify in the questions, we can come back to that question.
Pod concept, maybe, to isolating the pod?
Yeah. Oh, pod. Oh, sorry, core and pod design. So core and pod, what I'm talking about there is that if you build a cloud provider or a hyperscale data center, like what Google or Facebook or Rackspace is doing, their network architecture is not built on one single network in the data center. What they're building is they design their networks to have one core network which is unchangeable and is built to last for 10 years at a time. And then around that core is a series of pods. Usually it's 5, for an automobile enterprise, it's about 5 to 10 racks in a row. So each row becomes a pod, POD, or a segment of the network. And each one of those rack segments has its own dedicated network fit for purpose for that use case. It's an emerging design template. So if you're familiar with the various vendors who have different design models for designing networks, this is the emerging model for SDN platforms to be deployed into enterprises using this core pod. Buy a network inside of your data center and buy one network for each purpose. So perhaps you need to build a network that's suitable for SDN. Maybe you'd like to have a network suitable for your legacy layer 2 requirements. Maybe you'd like to have one built for a layer 3 ECMP. Well, go and buy the piece that works best for you. Core, pod. Have one of each.
Okay, excellent. Next question I have from the audience, I'm going to take that and then move on, is again from Chad. And he wants to know that since the dynamic nature of consumption and configuration of SDN, what type of reporting or trending is supported by these solutions, and are they built in, or are they do they support some type of API interaction or extraction mechanisms?
I think that Charles would be the best person for that.
You talk about trending, right, and analytics, really, if I understand correctly here. Yeah, absolutely, it is a good question, and it is. We had to do something about that, because looking at syslog and SNMP trap wasn't simply providing enough information for compliances and governance and all of auditors that we need to provide some reliable data. And for example, in the case of Nuage networks, the VSD, you can directly interface this with a Hadoop big data cluster, so you can pretty much gather all the statistics that your heart can content, and knock yourself out, feed this into a big data engine like Hadoop, and abstract all the trend, do all the analysis, do your predictive analysis to see how much capacity you'll be needing in the future. But you're doing this with the right tools and engine, finally, to make right business decision, and not simply looking at parsing logs and very scarce information. You have from the network the full and complete visibility feeding directly into an Hadoop cluster.
Okay, excellent. Greg, my next question is for you. Again, comes from audience member Moti. He wants to know if the controller is infected with malware. What could be the impact on the SDN?
That's not really a practical concern. In the same way that you wouldn't want to see the control infrastructure in your modern data center infected with malware, you would put systems in place to prevent that from happening. So planning for that sort of an issue is a bit like, it's certainly practical in terms of it's possible, but you would take the same steps to prevent it from having that sort of problem. That's the first thing, right? That's like saying, what would happen if your DNS server inside your data center was affected with malware? It would be infected with malware and you would activate something. What effect would it have on your network? None. The controllers themselves could operate, the networks themselves will continue to operate in the last known good state until you fix the problem. So you can actually turn the controllers off for most of the vendors. And maybe you just put this into your evaluation process to test it, and the network will continue to run without, but you just won't be able to make any changes. So not a major concern, because you would do good design and make sure the controller was in a zone which was isolated and safe, and that's very easy to do. Second thing is that the controllers themselves are usually hardened appliances. They don't run on general purpose operating systems and would not normally be suspect to malware. So solvable problem, I would think. Thanks, Ashar.
Okay, I'm going to take one more question before we move on to the use cases, because I think it's very important for the audience to understand the real world use cases. This question is specifically for Greg from Dimitri. He wants to know if there's any chance of SDN to appear in the enterprise. What are the benefits of the SDN, especially in the enterprise? Some of those are listed on the screen in the slide, but Greg, if you can help answer that question, that would be awesome.
Sure. So a couple of things. First of all, a lot of people think that SDN is years away and all that. I don't believe that to be the case. I've done 2 surveys recently which indicate that between 10 and 20% of people are either working with SDN now or have deployed it or are in production with SDN. Even if people aren't using SDN in a form that we think of it, what it shows is that people are hungry for SDN and what it can do for their networks. So it's not a question of if SDN arrives, it's when. So if we then say, in the case of when, what are the blockers for it? Now in history, we've always waited for technologies to prove themselves as stable, somebody to stand up and say, I'm using SDN in a big company, and therefore I can now say, well, that's suitable for use in my mission critical data center because that person over there is safe. So I'll start looking at that now. In modern networking and in modern IT, everything's been turned on its head by cloud providers. And we know that people like Google and Facebook and Rackspace, all of these high-profile cloud companies are using SDN technologies to make their networks efficient. And they've been public about it. And their reliability of those networks are at least as good as those in our enterprise data centers. They're not worse, they're not better, they're about the same overall. Same sort of outages, same sort of systems. If you're a CIO and you're looking at what Google and Facebook are doing, you're sitting there saying, why am I not deploying that in my data center? If it's good enough for them, then it's good enough for me. So I think that SDN is going to come into the enterprise much quicker than people think for these reasons. We've got permission, we know it works, we know it scales. All we have to do is scale it down to something smaller, and that is where enterprise data centers really have no reason not to jump onto SDN and start working with it. In terms of where it's going to come in, there's really no, in my way of thinking, all enterprise data centers will use SDN very soon. And it won't be because of the way you work today, it's because of the way you'll work tomorrow. It's not about, your first phase of SDN will be configuring, replacing the way you do things physically. So when you plug something into the switch, it goes into a VLAN. And today you get on the keyboard and you make your fingers down to bloody nubs by configuring something. What you want to be able to do is automate that so you can spend your time predicting when's the next switch going to be available. Pretend the time when do I need to move from 10 gig to 40 gig or things like this, right? And that'll be the first phase. The second phase will be tying the network to the orchestration platform. So as Ben spoke about earlier, these software abstractions, right? Things like VMware's VCAC or OpenStack or NFV, on different types of products, which will actually not be saying configure the network this way. They'll actually be saying, I need to add a new application, and the developer's going to write to an API that says, give me a load balancer here, firewall function here, data storage, deploy, and it's all going to be scripted. That's what you've got to be headed towards in terms of SDN. So in the enterprise, you're going to start small. I think everybody should be out there picking a solution and putting one into their data center or putting it on the roadmap for the next year or 2 years, and then getting it into their data center in a trial deployment, just like we did with VMware in the mid-2000s, just like we did with Linux in the late 90s, just like we did with PCs in the mid-90s, and start working with it and working out how we can bring that into our data center to be useful, and start looking at things like how microsegmentation works. How do I do security audits? How do I use it? How do I back this up? How do I make it reliable? You've got to exercise those muscles. It's like going to the gym. You've got to exercise these muscles to have fitness. So, pick a place where it can come in. Thanks, Asher.
Excellent. Some of these bullets are actually covered in the use cases that we're going to review, but I think one important one is reduced workload migrations. A lot of companies spend a lot of time and money in migrating workloads, and especially if they're large workloads, in their teams of people that are involved in that. So wanted to ask Ben. Ben, can you share your expertise and experience on this, how SDN benefits to reduce the migrations of workloads?
Yeah, absolutely. So again, it's all about silos here. If you have a traditional enterprise that has, a lot of legacy networking kit, might have kit there from several different vendors and all of it uses proprietary software, then moving applications between data centers or between our infrastructure that uses different kit becomes really difficult, because you need to think about how those applications actually play with the underlying networking and whether they're going to play nicely. Well, when you abstract that away and you make it all one common, consistent abstraction layer software platform, then that consistency means that your networking is no longer a barrier to migration. And theoretically, you can take a workload and you can move it across any of your physical infrastructure, because you have an abstraction layer that makes all of that physical infrastructure essentially common.
I think that one of the important points about it's not about actually reducing the workload itself, that is the consumption that the application consumes. It reduces the workload that your engineering team, your infrastructure team makes to move the workload around. So today, pre-DevOps or, as we do, we deploy once a year, and it's a mammoth effort. It's often very manual, and somebody runs bits and pieces and waves magic wands and, chicken heads at the database server and things like that. Reducing workload migration is about automating that in the infrastructure layer, and also making it so that the developer, when they do the deployment, can access the infrastructure directly. So it's a multi-tiered outcome. It's not a single thing, just to extend on what Ben said.
Excellent. So at this point, I'm going to hand it over to Charles, who's going to run us through 3 specific real-world use cases of SDN technology, and then we'll come back to the questions. So Charles, over to you.
Okay, thank you. And I think it's been a great discussion, because a lot of the points that we're finding in these use cases that I wanted to share came earlier in our discussion. So in this case, the cloud network infrastructure is really one of our customers, a large organization, that was getting requests to have test environment and a specific project or special project that could be deployed for a couple of days or a couple of weeks. So a different time frame, and each and single time they had to provision the infrastructure. And as we've mentioned earlier, with server virtualization, they sort of got that trick pretty early, and they were able to spin up new VM. That wasn't too much of a problem. But then they needed, in some case, to isolate the test environment from the production environment. So in the worst context, they were buying dedicated network switches to say, well, this is for this specific project. And that obviously drives their CapEx expense way high, consume resources in the data centers and so forth, right? That's probably the worst case. The best case is, well, they were sort of creating VLANs or trying to isolate it, but then there's still no gate against one test environment consuming more bandwidth, or there's still some security risk and all that. So what we introduce in this case is the concept of template or networking profile. And when we say, hey, when the new engineering department needs to have a test, it will always have these 2-tier, 3-tier, or firewall between the tiers. We'll have these templates that directly from the orchestration platform, the project owner will be able to select which templates apply to their project. And so without having to reconfigure everything, we push these configurations directly into the virtual switch and apply all these parameters, this isolation between the tenants in this case, or isolation between the projects, and that we're doing over and above the existing physical infrastructure. And that is perhaps another very important aspect, is that we don't have to go and reconfigure the existing networking switch. That was perhaps one of the secondary benefit that this customer realized, is that we don't have to go and configure and change and touch the physical hardware. Once we have our network admin who has done the job, traffic is moving from point A to point B, all of the rest of the configuration happens in the software layer. So in this context, we were able to reduce quite significantly the amount of equipment that the customer was purchasing. We were also able to steer some of the traffic to some firewalls or intrusion detection systems. So some security appliance that previously had to be forced inside the data path for traffic to go in and out. Now we're able to having them hanging in the data center, only steer some of the traffic when needed, depending on the template. So we don't have to buy expensive security appliance in front of every single rack, for example. So this was an example, relatively easy to deploy. There's, for example, we have Nuage Networks as a customer reference in the Nuage in France, which uses some concept very similar to this here. So maybe we can talk about the second use case that is also extremely popular. This is called data center interconnect, or DCI. And as we mentioned earlier, we have a very flexible, very agile, very mobile server environment. We're moving a virtual machine from one VM, moving the VM from one server to another is extremely easy. On unfortunately, the network is often on the way, right? It's in the way. It has to be pre-configured. It has to, the time it takes to configure it to match this. There's no way to match this from a server virtualization platform, right? So what we have done is in the Nuage platform is to make sure that the networking profile associated to the virtual network follows that no matter where. So you move it from one location to another. It has network switches from vendor A and network switches from vendor B at the other area. Doesn't really matter. It doesn't change a thing. Your virtual networks will have the same security profile, will have the same IP address, DNS name, and you'll be able to reach them from an application perspective just the same way, no matter where they are located. So with the data center interconnect, we're now able to move virtual machines from one data center to another. And this can be across layer 3 boundaries. This can be across a wide area network. And because the Nuage network, as I said, is pretty unique because we're also interfacing with the IP world, when we move a virtual network from one location to another, well, we simply start to advertise these new addresses in the new location. So the traffic is from the internet or from your IP backbone is automatically steered to the new data center. And this is pretty unique.
This is one of the biggest
actually.
issues.
Yeah.
Now, this is one of the biggest issues in data center networking today, is this ability of being able to move network workloads between two data centers. There's a whole bunch of practical structural issues that legacy networking just does not address well, and there's a whole bunch of pinch hit technologies. But this use of SDN is very powerful. It really does amplify what your data center can do. And more importantly, it doesn't just extend between two data centers, it scales infinitely to a large number of data centers. And with the right methodology, you can also take it into data centers in the cloud as well, into public cloud.
Exactly. So our customers use it, for example, for disaster recovery. Say, hey, I have my primary data center is on my premise, but in case of a major failure of my primary data center, all the workloads move to the second data center, and then we handle this and we'll advertise the new IP addresses and start the routing, update the routing entries and all of that, right? The second use case for this is usually extra capacity, where a customer say, I have most of my servers on my premise, but comes in a specific event or special event and I need to have more web servers, they can subscribe them from a cloud provider. And again, the same IP scheme, the same security parameter, the same logging and statistics and all that is simply extended into that public cloud to create an hybrid cloud environment with the same networking characteristics. So that's
I'm more of a
very,
fan
very
of the
useful case. Yeah.
I'm more of a fan of the active-active capabilities. So one of the things that I've learned over the years is that an active standby data center, the standby data center never works quite the way you think it does. And so running active-active always works much better than having active standby. And this tool, this SDN capability to do DCI does allow you to run true active-active. You can actually just move workloads, provided you have enough bandwidth between the data centers. You can't change the speed of light, underlying rule of networking. But this actually lets you run active-active in a very seamless way. It's beyond the capacity of us to talk about it in this session, but this is really the killer use case for most companies today.
Well, it is, and clearly, if we're talking about agility, then we need to be talking active-active because unless we have the ability to move and to change at will when required instantaneously, then that agility doesn't exist or is greatly lessened.
So guys, in the interest of time, we're running out of time. We've moved on to the next slide and the final slide, and then we'll come back to some of the questions given the time that we have left. So Charles, can you finish up on this slide?
Yes, and briefly then, this is, one of our customers, one of the large banks here in the U.S., who applied some of the two concepts of the previous two use cases, and did their exercise pretty well. They look at how much does it cost, how much time does it take to operate traditionally, and now they were able to measure after implementing the Nuage Networks VFP platform what were sort of the benefit out of it. And they were able to reduce their capital, their operational expense by half. Basically, the fact that they define these templates first, they define the networking profile and simply reuse them over and over again, save tremendous amount of time, 50%, right? They were also able to deploy the services 10 times faster. So by the time, we talked about 12 minutes or 12 days to 12 minutes and all that, in this case, they were 10 times faster to provision a new service, right? So, and that means that they were able to delight their customers 10 times faster by having these services available sooner. And finally, in this case, they were able to measure that the asset, the physical network environment and these sort of things were increased utilization by 40%. And I think this is also a tremendous gain because you don't have to upgrade to the newer routing and switching platform right away. You don't have to have the new features right away. So you were able to extend the life of the existing infrastructure by increasing the utilization out of these assets. So this was, one of the clear case of one large bank that implemented this and were able to provide some feedback on some of the gain after implementing some of these SDN Nuage solutions. Yeah. So I hope that provides some insight from some of the use cases we have right now with our customers.
So in the interest of time, we only have a few minutes left. I'm going to pick a couple of more questions. So the first question is from Moti Barkan. He wants to know what could be the impact of a design error and then the recovery process. So,
so it's Greg here. It would be the same as with the same error that we would have in any network today. So if you make a design error during your network, hopefully you have a review process or an audit process that would detect the design mistake. Or maybe the operations team would pick it up during the deployment. When we go to SDN, your operational cycle will change slightly in that you would design, the SDN platform would do validation of the change to make sure that it's valid and parameterized, and then you would do some testing before you would probably go to make it, scripting these software against the APIs and things. So you need to change your process, but it's not functionally different to what you do today.
Thank you. So the next one is, next question is from Chad. No, I think we've answered that question previously in a different conversation. So the next one is from Ivan, who wants to know how the orchestration layer that currently addresses some of the business drivers like consolidation, increased hardware utilization for data center evolution fits the story of the SDN expansion. In other words, do you see a trend or a possibility in standardizing the orchestration layer, or do you think industry is going to come up with some common approach? So Ben, can you take that?
Yeah, I mean, I guess what I can say is that I believe that, SDN is the way forward, and SDN is going to expand its use case and cover all of the networking assets and attributes an organization has. So does SDN help with the expansion of infrastructure? Clearly, yes. Is it going to be an enabler? I mean, beyond that, I'm not sure what the person asking the question is looking for.
Maybe I can expand on that. SDN is still an emerging technology, and up in the orchestration layer, there's not a lot of standards for APIs and API interchange, but we are seeing a thing called Open Daylight. Probably the Open Daylight project will document most of the APIs that people will converge on. So if you're looking for guidance and leadership around the future of SDN, my suggestion is, look at what Open Daylight is doing, because most of the vendors participate there, and where interoperability needs to occur, they then agree with it there and then bring it home to their own products. OpenStack, of course, is the other one, which is open. Again, most of the vendors are contributing, and then when they come up with some sort of consensus, they bring that back to their products. So if you want to see where the standards are emerging in SDN and orchestration, go and have a look at OpenStack and Open Daylight would be my suggestion in the short term.
At this point, we're out of time. I would like to thank the panelists for taking their time to be on this call, and thank all the attendees to take again to be on this webinar. We will respond to any questions that we have not answered, as mentioned before, and the slides will be posted. Thank you very much, and have a good day. Bye-bye.